Okay, so we're going to talk about elimination reactions. Elimination, we're, by the way, getting close to the end of the reactions. Elimination is what it sounds like. I'm eliminating something from a hydrocarbon. So I've done addition, I've done substitution, and now I'm eliminating or taking away from a hydrocarbon. And what this does is it makes an unsaturated hydrocarbon. So I'm able to make a double or a triple bond by eliminating something from that organic compound. So we're going to go through this really quickly, get through elimination. And then I know that right now it's probably really confusing thinking about all the different reactions and trying to figure out what the differences are. So there's going to be a video where there will be a worksheet that you go through that has different reactions. And I will go through that worksheet and explain each individual question and the types and what's happening. And that will really help bring everything together. So look for that video really soon. But anyways, elimination. So what am I doing here? An elimination reaction is a reaction that involves a removal of atoms and or groups of atoms from adjacent carbon atoms, resulting in a double or a triple bond. So these reactions can follow two forms. So there's two types of elimination reactions I can have. Both involve hydrocarbon derivatives. So one starts out with just an alcohol. That's all I need is the alcohol. And then with a catalyst, it ends up making an alkene and water. So the OH, the hydroxyl group, pops off. And then a hydrogen from an adjacent carbon. And we get an alkene and water as a result. The other one involves an organic halide. So I have a halogen atom on that hydrocarbon. And then from there, by reacting with hydroxide, hydroxide takes away a hydrogen. The halogen leaves as a halide ion, so it has a negative charge. It's an anion, and I end up with an alkene there as well. So this is a method, again, of making unsaturated hydrocarbons. So here's an example of both. Here's propane-1-ol. So I have my hydroxyl group here, and this is my only reactant. So the only thing that you could imagine happening here, if I have this starting out as a single reactant, is that something has to come off of it, right, in order for me to get two products. So what takes place is this hydroxyl group and this hydrogen ends up coming together to make water, and then I end up with a double bond here. So I get prop-1ene and I have water now as two products. So if I have alcohol as my reactant, that's what's happening, is elimination, resulting then in my alkene and water as a product. Okay, another option I have is having a hydrogen halide reacting with hydroxide, and then I end up getting water, the halide ion, and then again an alkene. So here I have two fluoropropane and hydroxide. So what happens is this fluoride is going to pop off because this H is going to bond with the hydroxide, and then I end up with a double bond happening here. And again, it's always going to be with a hydrogen that is on a carbon adjacent to the one that has the halogen on it. Now, I actually have two different options of which hydrogen can leave. This hydrogen could leave, or it could be one of these hydrogens here. Both are options. So I end up with two different products. I could have but-2ene or but-1ene. And then I have water and I have fluoride as well. So interesting, the different kind of products I could have out of this. So that's two different elimination reactions that we can have occurring. Again, this is making alkenes. Why don't we go through another example here for you to kind of think about or try out and see how you do. So let's say we have something like CH3 to C. This is my alcohol OH. CH, CH2, CH3. So if this is my only reactant, well, this would be elimination, right? I have my hydroxyl group, my alcohol, and this is going to leave with another hydrogen to make products. So what products could I end up making? This was way too similar to the example we had to begin with, but this could leave, and then I would have either this hydrogen or this hydrogen leaving to make my water. So I end up with two different products. I could have CH2 double bond, CH single bond, CH2, and CH3. That's if this hydrogen leaves with the OH. Or I could have instead CH3 to CH double bond, CH to CH3. So that would be if this hydrogen leaves to match up with that OH. And then I end up, of course, with water as well, HOH, can't forget that. Need to draw that product. So I could get but1ene or but2ene out of this reaction. Now let's deal with a halogen one. And let's actually go ahead and do something a little bit fancier. So let's kind of draw a cyclohexane type thing here. We're gonna get fancy. This is gonna be so fancy. You ready for this? We're gonna have a chlorine on this and a methyl group on my cyclohexane. Ooh, that's fun. And I'm reacting this with hydroxide, OH minus. So this is again an elimination reaction. So this is going to pop off this chlorine. Okay, and I need to figure out what hydrogens can pop off for carbons that are attached to the halogen carbon. So it could be this hydrogen popping off, these hydrogens popping off, or one of these hydrogens popping off. Now I hope that you can see that these hydrogens and these hydrogens are equivalent. So one product I would end up with is this one right here, CH3, double bond to CH, to CH2, to CH2, CH2. Oh, I ran out of room here. CH2, single bond. So, oh, that's ugly, but you get the idea. I would have the double bond right here, which would be the same way as having the double bond right here. So this would be 1-methyl cyclohexene. 1-methyl cyclohexene. But the other option is I could pop off one of these hydrogens, right? And then I would end up with this product, which is kind of interesting. So a CH2 right here. And then I have CH2, 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 and C. Interestingly enough, we haven't learned how to name anything like this. So we're going to leave the name off of that because I don't have the double bond in the cyclo, but we can still draw it and talk about it, and that's fine. The other thing that we'll end up having as products for this is, of course, water, because the hydrogen that pops off and the OH make water. And then now I've also got a chloride ion floating around. Important that I say chloride ion, not chlorine. And that's floating around as well as a product. So these are all the products that I end up getting. And again, I'll get a mixture of both this product and this product being made. So there's two more examples. Again, if the reactions are confusing, I get it. It's often a struggle. Don't feel bad. Okay, as we go through a mixed reaction worksheet, I'll be giving you the worksheet and then posting a video key working through it, which will really help for you to have some more understanding of these reactions. All right. That's it. Have a good rest of your day.